So let's have a look at a couple of methods of adding and subtracting with standard form. One way of doing it is by converting both of these into regular decimal numbers. So 3.21 times 10 to the power of 3, and we can convert into 3,210, and 2.47 times 10 to the power of 2 we could convert into 247. So then it's possible just to add these two together in the regular column. So 0 add 7, 1 add 4, 2 add 2, and then the 3 on the front. So 3,457, and then put it back into standard form. So that would be 3.457 times 10 to the power of 3. And that's fine, that works nicely, but it becomes quite tedious, especially when these numbers become increasingly large, so times 10 to the power of 23 for example. So there's another method that we recommend in this situation, which is to add these together by making both of their powers the same. So here I'm going to turn this question into something times 10 to the power of 3. Now what I've done is I've multiplied this part here by 10, I've raised the power by 1, and to compensate for that I've had to divide this part here by 10. So I've made that into 0.247 times 10 to the power of 3. Now I've still got this bit over here, and I'm just going to add this and this together. So I'm going to add the 3.21 to the 0.247, and I know that the times 10 to the power of 3 add times 10 to the power of 3 is still going to remain as something times 10 to the power of 3. So in a column I'm just going to add together the 3.21 and the 0.247, and that will give me hopefully the same thing as before. So I've still got 3.457 times 10 to the power of 3. Let's try doing this with this question here with the negative powers. So I'm going to make the powers the same. I could do this either way around, but usually I find it easier to raise them both to the same power. So I'm going to raise this one to become minus 4. So I'm going to turn this one into something times 10 to the power of minus 4. So I've effectively raised this part, so I'll compensate by lowering this part. So I get 0.67 times 10 to the power of minus 4. So I know that the answer is going to be something times 10 to the power of minus 4. So I just need to add together the parts. 7 add nothing is 7, 6 add 8 is 4, carry the 1, and I get 4.47 times 10 to the power of minus 4. The same rules hold when taking away, so let's convert both of the powers to the same thing. So I'm going to raise this right hand side to something times 10 to the minus 3. So I've had to raise that side by multiplying by 10, so to compensate I'll divide this side by 10 to get 0.82 times 10 to the minus 3. So I know that the answer is going to be times 10 to the minus 3, so now I just need to sort out the column. So 2.37 taking away 0.82. 7 take away 2 is 5, 3 take away 8, I have to borrow 1, and that gets 1.55. So the answer is 1.55 times 10 to the power of minus 3. This final example, same thing again, so we're going to make the powers the same, but this time they are 2 apart, so we're just going to need to be a little bit more careful. But I'm still going to raise this one to make it the same as that one. So I'm going to make it times 10 to the power of 4. To do that, I've had to multiply this one by 100. So to compensate, I'm going to have to divide this side by 100. Now if I divide this side by 100, I get 0.026. And then I can tell that the answer is going to be something times 10 to the power of 4. So I just need to add together in a column 7.3 and 0.026. When I do that, don't add them together because I'm taking them away, so that would be a silly mistake to make. So I need to put the zeros on. It's not the ideal subtraction. So 0 take away 6 can't do it, 0 take away 2 can't do it, so I'm going to borrow all the way across. So borrow 1, turn that into 10, borrow 1 again, turn that into 9, and where we go, 10 take away 6 is 4, 9 take away 2 is 7, 2 take away nothing is 2, and 7 take away nothing is 7. So the answer is 7.274 times 10 to the power of 4.